Well, good morning, everyone. Today, our seminar speaker is James Feston. It's my pleasure to introduce James today. I never met James before, but I heard about this company for a long time. The company he works in is Insects Limited. It's located in Indianapolis, Indiana. This is a very innovative company. They produce all kinds of pheromones for stored product pest protection. So today he will talk about the role of pheromones in food safety programs. Before that, I want to just give a brief introduction about James. So James got his bachelor degree and master degree in entomology at Purdue University in Indiana, where I worked for 6.5 years. That's why I was actually very familiar with his company. So he's the product development director after he finished his master degree in entomology. So so he got his degree, let's say from 2009 to 2012 for his bachelor degree, and for the master degree from 2013 to 2015. So since 2015, he has been working as product development director for the company. So James, it's your turn.
Thanks, Chang-Lu, for that introduction, and thanks for inviting me here today. So the title of my talk is the role of pheromones in food safety programs. And so ahead of time here, I sent this article that is about a food safety recall that happened about 11 years ago now that concerned warehouse beetle in some baby formula. And so but also during this talk, we'll talk about insects, how to monitor them, and how to use pheromones. And but it's ultimately about this food safety. And so food safety is a serious business, and the primary goal is protecting human and animal health. And it can involve huge sums of money, as we can see from this story. It was $100 million of sales lost from that issue. And so they had a stored product insect, and that was warehouse beetle. It cost them that money. It damaged their reputation for some time. And I'll end up referring to this story a few times along the way. And I chose it because I really think it helps put into context the importance of food safety and pest management in food facilities. So we mentioned how much that one company spent on that issue, but I also want to talk about the cost on a larger scale. It's generally, we think it is about 10% of GDP in developed countries is lost per year due to insect damage, and in developing countries it's even higher. And at the bottom, I've got some little GIFs put together of some insect damage from a few of the stored product pests that we will talk about. And none of these are more than over a year, or none of these are more than a year. So it just shows the kind of damage that they can do in relatively short amounts of time. Going back a bit, we know that this insect in stored products is not a new problem. The ancient Egyptians were one of the first societies to harvest grains on a large scale. And the same pantry pests that we know today have been eating our stored seeds and grains since then. Granary weevil, lesser grain borer, red flower beetle, all have been discovered in grain stores in ancient Egypt. These insects were happy to transition from life in the wild to one inside our homes and in food processing facilities for as long as we have been processing food. So I'll go over some of our star players in terms of food safety and in food facilities. We affectionately call them the dirty dozen. Each of these insects is a major stored product pest that is dealt with in the food industry. Each of them has some unique traits. Many of them overlap with food sources and life histories, but they all require knowledge of their biology and their chemical ecology in order to effectively monitor and control them. So I will just go over some of these insects relatively briefly. I want to start with Indian meal moth due to its unique position as the most common stored product insect pest that we encounter. Thankfully, though, it has one of the pheromones that we understand the best, and is also the target of several pheromone technologies. One of the reasons that it is public enemy number one is that it has a very short life cycle, and it's attracted to a wide variety of food ingredients, mostly dry foods, some dried fruits, but seeds, nuts, pet food, corn, cereals, this sorts of thing. And it's notorious for the webbing that it makes. It makes a huge mess on the foods that it infests. And here you can see this webbing that it makes from the glands in its mouth. And it can completely cover the food items that it infests. And it does this to protect itself from predators and to create microenvironments in which they can thrive. But here is just a quick video of some mating, but really the point is there is a shot of some egg laying. And this egg laying ends up being important in food safety because they're extremely targeted in where they can lay these eggs in terms of packaging. And I'll show another video of it here after this in a minute. But see how she will lay that egg directly into the crevice of this piece of oat, and she'll lay it there to help protect it from in cracks and crevices to help protect it from other insects. That little larva pops out, crawls into the food, is now protected and feeding. That first instar larva is so small that they can get into spaces that are the thickness of a dollar bill. And once they get bigger, the problems don't end because they can chew through thin plastics, they can chew through papers. Most often they'll pick a defect in the packaging that already existed and exploit it to make it slightly bigger and enter. They'll go after seams and folds and cause problems that way. And it's those food odors that are coming from the bags and packaging that she will seek out to precisely lay that egg. And like I said, I got a thing coming up where we'll see that happen. And just reiterating that the eggs are super small, tiny. All right, so here's where we mocked up a scenario where you can see this happen. So this is a bag of rabbit chow, and if you look down at the bottom where they stitch this bag together, there are small holes where the stitching goes through. So the female moth can show up, and she can choose to, in this case, that hole is enormous for her. She can choose to lay that egg directly into the hole, and even if she can't lay it directly into the opening, she can lay it next to the opening, and that very, very small first instar larva crawls right into the bag and infests the product. Very briefly talk about Mediterranean flower moth. It's not as common as Indian meal moth, but it's still quite common. They're important because they use the same pheromone as Indian meal moth, which you would think would cause problems since they occupy the same food sources, but they end up getting around this by calling at different times of the day. So it's kind of an interesting thing about them. We'll move on to some of the beetles. The beetles are not as responsive to pheromones as the moths, always, but a couple of them do have some unique pheromone responses that are interesting to talk about. Warehouse beetle, that's the insect we talked about at the beginning. I got a little video of them walking around. We'll see some of the same targeted egg-laying behavior, but I think one of the most interesting things about warehouse beetle is not the adult stage, but the larval stage, and we'll see that in a couple slides as well. There's some shots of that, and I could see if they'll lay it in. There we go. So they can do that same oviposition where they can pick a specific spot to lay that egg. There's that. These beetles, like a few of the other stored product beetles are attracted to a wide variety of food products. They're kind of the goats or the garbage disposals of the stored product world. They can go after corn, wheat, rice, milk powders, proteins, other insects, and they don't need very much food to actually set up shop and develop. So, and that's kind of what we'll talk about here is this larval life cycle is it can be very interesting sometimes. So I've got up at the top, we'd see 32 to 50 days is sort of the optimal life cycle. But when they are stressed or conditions are poor, they can remain a larva for over a year. And they can also enter diapause as a pupa and wait to eclose for extended periods as well. The best example I have of this on my desk at work, I have a little vial with a warehouse beetle larva that I got from a customer that wanted me to ID it for them. They had assured me that they froze it for several days to make sure that it was dead before they sent it to me because they didn't want it to infest our building. That ship has sailed. We already have bugs in the building. But anyway, I took the that little larva and it ended up being alive. I put it in this vial with one of our domestic food lures, and it's going on close to 2 years as a larva still and has molted about 12 times. So it's a little crazy. And what's important about all of that molting when these conditions are not right is that they have these specialized setae that have little barbs on the end, and they can be a real problem for older people, infants that ingest those hairs. And you can see here's 30 skins from 5 larvae. The larva on my desk has about 12 on its own. So you can see that they really just make a big mess. And that was really what caused the issue in that story from the beginning is people were worried that this would happen. Turns out that there was only actually one container that was infested, but it triggered that, this issue triggered $1 million in remediation and an additional 100 million in lost revenue. So keeping insects out of food and using monitors and pheromones is critical to save money and reputations and keep people safe. I will go over the cigarette beetle and drugstore beetle relatively quickly. They respond well to pheromones. They'll easily fly in warmer temperatures. They'll eat a variety of foods, just like warehouse beetle. They're kind of the goats of the insect world. But they really specialize on herbaceous material, leaves and stems and seeds from plants like tobacco, dried flowers, and lots of spices. You may have even gotten them in spices before. I did some consulting with a company that sells tea in tea bags, and they had this continuous problem where they were getting a product from Morocco that was thoroughly infested with cigarette beetle. Here's sort of their conspicuous damage that they'll cause to harder foods like dog biscuits and pretzels. They usually have this kind of shot hole look to them. And red and confused flower beetle, these guys are often grouped together. They are 2 separate species. They are interesting in terms that they don't use as much of a sex pheromone as they do an aggregation pheromone. They have a longer adult lifespan than cigarette beetle, which only lives several weeks, and Indian meal moth, which only lives a couple weeks. So they really they don't care as much about trying to find that mate right away, and they also generally occupy places that have real sanitation problems, and there's food everywhere. And so the pheromone is not always as compelling as it is for some other insects. Here's some of the trails that they leave in powdered food. You can see this conspicuous trails that they make, and here's a little example of how that happens. Of course, the adults can also create the same trails, but this is how they do it. Like some of the other beetles, again, it's that kind of variety of foods, but They definitely prefer more of these fine powders, like flowers, like their namesake. They really only need just that small layer of spillage to be successful. They can chew through paper, and they will fly above, the red flower beetles anyway, will fly above 81 degrees. Confused flower beetles, apparently that's why they're named that way. They're too confused to fly and they don't fly. So in our focus on food safety, we'll talk about food facilities and understand where these foods are processed and stored. 99% of the time, food facilities are complex places. And I say that not meaning just that there's floor plans that are complicated and there's food production operations and equipment and all that stuff, but really, if you think about it as an environment, a complex environment for these insects that has both biotic and abiotic factors, that affects how the insects will navigate the space, that affects their growth and development and their reproduction. This picture is an example of these different kinds of environments. We've got a couple things going on. We've got a receiving area on the left and kind of a catwalk area in the same place up above. And you'll have all sorts of things going on here. That receiving area has doors open, lets rushes of warm or cold air in, depending on the season. It may dilute the space if there are pheromone or food odors in there. There up above, there's equipment that keeps that area warm. If there is chances for spillage, this is an area where the insects can focus on, and that's all just in this one room with multiple environments. Machines used for processing are notorious for harboring insects. One of the strategies that I will use if I'm doing a consultation for a food facility is I'll bring one of these instant read thermometers, and as you walk around the facility, you can point it at different pieces of equipment or areas in the room and try to identify hot spots and cold spots and see if you can identify these micro environments. 9 times out of 10, if you've got a facility that sort of has a sanitation issue, has this kind of equipment and has covers over the front of the equipment, you see that it's warm, you lift up the cover, you will find insects. Same thing with, there's these unexpected places where insects live in food facilities. So even up high next to stairs and pipe chases, these small amounts of fines will find their way and settle on ledges and different places inside the facility. And you will see these telltale trails of evidence of insects. And it's any horizontal surface is susceptible. You can even see in that bottom right picture, it's not even a fully horizontal surface. Even rounded tubular surfaces will collect enough dust that can support larval insects crawling around. Spills are obvious places. Oh, sorry, I went ahead a little bit. Corners are places that can also be microenvironments where there can be small humidity and temperature changes or differences between that area and the larger space, especially if there's conduits and piled food and that sort of thing. And spills, for example, are obvious places where insects can grow. And these kinds of spills are extremely common in food processing facilities, depending on what they're doing. And you would be surprised, or maybe not, how often a spill like that might stay there for days or longer at a time. And you can see that they, their version of sanitation in this case is you can see the broom marks where they've all just kind of piled it up around the machine there. Cracks and crevices are very obvious places for insects to go. They're small. It's a protected environment. It's really great places for them to try to look to find harborage. The point of all these of this is to point out that these food facilities are large, complex places, and we need to be able to monitor them, the insects in these places. And so how can we use pheromones to do that? Before we get to that part, as I was looking for pictures to use, I couldn't help but land on some of these old insect traps. One of them, one at the top left, is a fly trap, a Victorian fly trap. The one in the middle is an old cockroach trap, apparently. You'd put beer or bread in the bottom of that, and the cockroaches would crawl and fall in the trap on the little flaps there. And then the bottom one is a pitfall trap that looks remarkably like modern pitfall traps that we use now. But trying to catch these now is obviously a lot easier. We have sticky traps and better technology and better baits and lures. But they still follow the same ideas. We've got hanging traps at the top, we've got some sticky traps in the middle, and we've got our pitfall traps, just like the antique one there, but a little bit enhanced there. Those traps are all good, but they're only as good as the lure. And so if you don't use the right one, it's not going to be as helpful unless you really are just setting out a blunder trap. But what lure you use depends on the insects that are involved, and what kind of a situation that you're in. So you're going to use hanging traps for flying insects, pitfall traps for crawling insects. But in the cases of insects that actually do both, like cigarette beetles, you may choose one that is a combination of the two, or you may pick what best reflects that environment in the food facility that you are at. We'll talk a little bit about trap placement in food facilities. There's a few things to keep in mind. There's always a budget involved. And so you can only put out so many traps. I mean, you would love to be able to put an equal number of traps throughout the entire facility and be able to have somebody check them, once every week, and that would be great. But food facilities, they don't have the budget for that, or at least they claim they don't. And so we have to make concessions about where we put the traps. So in this case, this map makes sense. We've got dry food goods in the middle, and each of those crosses represents where you would put a trap. You've got a nice grid pattern next to the foods that are going to be highest at risk. Our canned food area, we kind of put a little burgeoning perimeter. Still, we're kind of focused on our dry goods more than we are our canned goods. Canned goods really only end up being a problem if they get damaged, and the kind of insects you get from that are flies and that sort of thing anyway. And it's very easy, even by smell, to locate the problem and get rid of it. And then you can see that even in the air handling room, we put at least one trap in there, just because there can be these unique situations, and you don't want to discount that there could be no problem in there, but you also don't want to devote a ton of resources to it. And really putting out traps, the way that facilities are designed for the most part are in these sort of large logical sort of constructions. So that natural grid is easy to find and place your traps, but you just have to know, you could put them everywhere, but you need to focus on the places that are next to the items that are at risk. And so where do we start after that? We've picked our grid, we know our insect. There's other places that we need to pay attention to, like our cracks and crevices that we talked about before. So knowing these specialized areas and knowing where to sometimes deviate from the grid to place special traps. So all that stuff that we talked about before. When you gather that data, it's critical to be consistent more than anything. So if you have the budget to do a weekly test, that's great. Do it weekly. If it's bi-weekly, that's fine. Monthly, whatever it is. The point is that in order to get consistent data, you should be trying to collect it on a regular basis. You want to record only the new insects that are in the trap, and eliminating or replacing traps when they are 50% full. Because the trap that is, the more insects that get caught on it, the fewer additional insects can be caught, and the likelihood of catching an insect that encounters it goes down, especially in cases when the trap is very full. You can see in this, on the one on the left, there's all the scales from the Indian meal moth wings are on the glue. You couldn't catch more on there if you wanted to. And the other thing that's important to keep in mind is that it's not always important. You really don't want to fill a trap with a bunch of insects, because trapping is a survey rather than a census of the population. So you're looking to find representative samples to try to make assessments. And it's also important to know the biology of the insects when you're making these assessments, because the for example, flower beetles, only 10% of the population is an adult at any given time, and only a fraction of those adults actually get caught in the trap. So it's important to keep that biology in mind. So going back to our story from the beginning, we can talk a little bit about economic injury levels or action thresholds, because they're different between facilities, right? So that an example is a bird food facility that serves the outdoor bird feeder market. They might have quite a bit of tolerance for insects here and there in their product. But the formula company at the beginning has almost no tolerance for insects. It was just that one tub that was shown to be infested. And again, remediation was $1 million and $100 million in losses. So that economic threshold can look different depending on what you're looking at. But hopefully what you can get when you do some of this monitoring is data like this. It's older, but I think it illustrates the point really well, where you can see 3 years in a row, and we're looking at Indian meal moth counts. And we can see the blue line is May 15th, sort of the beginning of bug season in this warehouse. And we can see that year over year, it's about when they have their problem. It dips down. They probably do some sort of treatment. Also, there's the generational difference, but we get about 3 generations per year. Middle year, we got about 4. But the reason that we collect this data is to be able to create information like this, where we can look at these historic trends. And so those action thresholds and that historic data is part of this larger puzzle, and all those pieces have a price, and the bedrock of the whole process has to be monitoring. And without those numbers, there's no good way to make decisions. So we use our monitors, and we use pheromones specifically to drive our data collection effort. So we'll talk about pheromones. There's a few different kinds that we have in play in food facilities. There's sex pheromones, cheromones, and food odors, aggregation pheromones, and repellents. And here's some of the ways that examples of how we use pheromones to help us in food facilities. We can monitor, which we've already talked about. We can try to pinpoint infestations after we've monitored by placing traps in specific locations. We can try mass trapping to lower the population, catch as many as we can. And then we can do mating disruption, and we'll go over that one in a little bit more detail in a minute. But we can also use the pheromones to determine the presence or absence of certain insects, which is really important in quarantine situations, where detecting certain insects can set off a cascade of very expensive consequences. Think Capra beetle. You find one of them, bad things happen. Action thresholds we talked about. And lastly, it's really about using pheromones to create this trending and predictions that can inform pest management decisions like foggings or fumigations or other treatments. We will briefly go over just the standard model of how pheromones work. I'm sure you're very all familiar, but basically the female moth releases pheromone, the male moths will travel upwind to try to find her, and the monitoring traps do the same thing as the female. Hopefully they find that trap and get caught. It's pretty straightforward. These pheromone, the pheromone is present in these facilities as sort of plumes that are carried by the air. They end up being present in these pulses or strings as they are carried and become diluted over distance or become broken by air currents or forklifts driving around. And there's all sorts of things that affect the distribution of the pheromone when it comes from a trap, a female, whatever. And so here's sort of an idealized pheromone release situation. These are traps that are placed in a perfect grid, and they're spaced to cover an entire space equally. And they've got that grid perfect. And you look at the traps and you say, oh, I catch more in these 4 traps here. I look in the center of them and I find the point source, easy peasy. But in real life, they're complex facilities and everything has its own issues. There's difference in building envelopes between places, insulation, air conditioning, you can have giant fans moving pheromone around, and ultimately, as a food production facility, there's materials moving around. So you could be proud of yourself. You feel like you've pinpointed exactly where the problem is, and it turns out the day before that pallet was moved across the warehouse to who knows where and is now totally infesting something else. So lots of challenges. And we'll just go over some of the things that happen with pheromones. One of the things that the different things that you can look at to try to determine what's happening. And these are sorts of things that as a pest management person in a food facility that you're thinking about. So what happens when you have occasional low captures? It can be a few things. It could be insects coming in sporadically from outside, isolated product with low infestation, or it's a sign of a future problem, perhaps. You could have constant localized high captures. This is most of the time it's sanitation issues or outdated products. The food facilities, a lot of times they will decommission a piece of equipment, or it only gets used for the first quarter of the year when they make a particular product. And instead of cleaning it all out and covering it and putting it away properly, they just leave it totally dirty and they shove it in a corner, and it becomes a hot spot for insects. And then we will find these, occasional high capture from that kind of stuff. You can also find it in places that don't have optimal conditions for dispersal. So imagine a distribution center that has a combination of food. It's a mixed use facility. It's got a combination of food and hard goods. So in one aisle, they've got birdseed, in another, they've got wheelbarrows, and in another, they've got, just non-food items and food items mixed. And so it becomes more difficult for the insects to find these patches, especially as things move around. Constant high capture is outdated product, but almost always this is going to be, occasional high capture. Outdated product, it can happen when raw materials, let's say oats or corn, something comes from a supplier to a food processor, but that supplier has insect issues, and every time you get that new delivery, you get a spike in catches. Constant high capture is a sanitation issue, almost always. It's a flour facility, something like that, a mill, where they just have constant spillage and constant dustiness, and everywhere you look are those little trails of insects walking around. Constant low captures, you can just have conditions that are not always optimal for growth. There's plenty of food items, but for various reasons, maybe the temperature is too low, so they're persistent, but you just don't get that that high level. So cover some special uses of pheromones like mating disruption, mass trapping, and outdoor trapping. Outdoor monitoring is fairly straightforward, but a couple of slides ago, we talked about those constant low-level catches possibly being caused by outdoor pressure. And so pheromone trapping outdoors can help you answer that question and see if it's really true. It's very easy to set up a perimeter around the building, keep it 30 to 50 feet away. You don't have to do this all the time, but you can use it in situations where you want to answer this specific question. You test it for a couple months, see what the outdoor pressure is, and see how things go. I've got a little story about this. I'll try to make it quick. I've got about 8 minutes left, but basically, this is a dog food facility that had an issue with warehouse beetle, same issue from the story at the beginning. And they were catching a lot of them, and so they performed a fumigation. Fumigation went flawlessly. They knocked down the numbers. They weren't catching anything for a week. And by week 2, they were catching the same, if not more, insects that they were at the beginning before the fumigation, which is difficult to do. It would mean that all of these adult beetles were not killed. So the suspicion is that they maybe were coming from outside. So they did this outdoor trapping, and they narrowed it down to a nearby railway depot that served a grain milling facility. And there was a quarter-mile stretch of spilled grain on the ground that was absolutely totally infested with warehouse beetle. And the pet food facility had an interesting issue up at the top of that tower. Depending on the time of the day, there was positive or negative air pressure coming out of that roof. And so during parts of the day, it would pump food odors out and draw these warehouse beetles from that nearby rail yard. And at other times, there was negative air pressure that was pulling them into the building. And so that solved the riddle of how that fumigation appeared to fail. Mass trapping is as easy as it sounds. It is using high capacity traps to try to catch as many insects as possible. Ideally, both males and females. You don't see it being used in food facilities too terribly often, but I did have one example. It's not a food safety issue as much as it is, it's a cigarette beetle in a tobacco factory. I've got a picture of a rain gauge there that will make sense in a second, but basically what was happening was in the tobacco facility, they have huge bales of tobacco that are like meters wide and tall. And they set them out in a big warehouse situation to dry out and cure and develop the sugars and whatever they need. And so during that time, it's extremely susceptible to cigarette beetles who will come in and infest those in ginormous numbers. And this facility stopped using regular sticky traps to try to quantify how many insects were there. And they switched to large rain gauge looking bucket traps that they put marks on, and then they would measure the inches of cigarette beetles that they would catch per day to try to estimate the population. Gross. Mating disruption is, it uses large amounts of pheromone released to try to confuse the insects. I'll talk a little bit about how it works in a second, but it's used most often for Indian meal moth, partly because they respond so well to the pheromone and because it's relatively inexpensive. It's about $3 a gram compared to $50 or more per gram for some of the other insect pheromones. It's registered as a biopesticide because it is controlling insects, even though it doesn't do it directly, and you can't exceed certain amounts in a facility per year. So you can't just saturate the entire place totally with ridiculous levels. But there are two models for how it works. There's a non-competitive model and a competitive model. We will go back to our basics here. We've got female releases, the lure releases. Here's the competitive model where you saturate the area with dispensers, but not so much that the insects don't have any idea of what's going on. They can still attempt to locate these point sources, but the idea is that you want them to locate the non-female sources and delay mating if you can. The non-competitive model releases so much pheromone that there's a cloud of it in the facility, and the male insects become desensitized altogether and hopefully stop flying. There's some work that shows that even if you can't get them to stop flying, just delaying mating is enough to have a real impact. Every day that they do not mate, there's a 22% reduction in viability of the eggs. So here's an example of a place in Indianapolis that we worked with a few years ago where we did mating disruption, and you can see at that 8th week, mating disruption was placed, and the number of insects caught in the traps went way down as they struggled to find point sources of pheromones. Like everything, there's pluses and minuses to mating disruption. One of them is that you have to watch out for when there are low sanitation or poor sanitation issues and high populations. They'll just find each other anyway, even if they're not flying. If there's enough insects that can bump into each other, they'll find things and mate. And an example is this bag too, even in smaller scenarios. If that bag is already thoroughly infested with insects, mating and it's closed, mating disruption could get in there. The pheromone could get in there. It could confuse the insects, but not enough that they don't find each other because they're right in close proximity. I'll just go through this really quick. There's other candidates for mating disruption. One of them is cigarette beetle. It has the adults don't live for very long and they're very responsive to the pheromone, but the biggest deal is that it's expensive. It's in the process of being registered, but we'll see how successful it is, just because it costs so much per gram to make that material. I bring up webbing clothes moth super briefly because we attempted to try to use it for mating disruption. It's not a food insect, but it represents that issue that you can have with mating disruption in small spaces and high populations. So we simulated a closet, we inundated it with pheromones, we put some insects in there, and they were able to reproduce basically with no problem. There was a little bit of a dose-dependent response, but it didn't matter. There was, when there's 3,400 insects in a small closet, it didn't work. And to wrap up, I only have a minute left here, but to wrap up, I just want to talk about some of the advances in technology, the marriage between pheromones and technology. We've got on the left a device that is from Sensor Development Corporation. It is a handheld pheromone detecting device. It's got this wand, you can walk around with it and pick up the pheromone odors that are coming off of the insects, and hopefully use it to make different pest management decisions. On the right, we have the sight trap, which is we actually developed in-house. It uses just the industry standard sticky pheromone board and pheromone lures, but it's attached to a Wi-Fi enabled camera, and that pairs with an app and a website where you can see almost near real-time insect population changes. I see this portable sensor device being useful in food safety scenarios where, remember we talked about how a food processing facility gets in a bulk shipment from somewhere else, but that bulk shipment is infested with product. This is the kind of thing that you could test that truck before it even got into your facility, and if it had a pheromone, an unacceptable pheromone level, you could reject that shipment and make them either treat it in some way or take it back. Ultimately, not bring it into your facility and infest everything. This is on the picture on the right as a little example of some pictures taken by our sight trap. This was a scenario. This is a real scenario of a facility that had an Indian meal moth problem, obviously, but it was on a 2-week inspection rotation. And so with that sight trap, they were actually able to see it. This is about 18 days, by the way, of pictures. So here we are at about day 7, and this is when we noticed that there was a real problem. We were able to contact the facility and start getting treatment options scheduled ahead of time. And so they got to find out a whole week early and start making those decisions ahead of time. So they ended up performing the treatment on day 19, where if they had found it on day 14, they would have been looking at 6 additional days before they would have responded. So that's the kind of power that that kind of technology can provide. And then at the very end here is going forward, we've got this website where we hope that we can help people plot trends ahead of time and make that easier for them. We also are collecting data that we can feed a machine learning algorithm to help us spot trends based on a variety of inputs, including temperature and humidity and any other data points that we can integrate to try to help people make decisions before it is too late. And that concludes my talk for today. If there are any questions.
Sorry. Everybody can ask questions.
Hi, yeah, I had a question.
Sure.
Now, what was my question? Right. Sorry about that. So you were talking about how some of these pests can actually be generalists or opportunists, like particularly the beetles that are coming into it. Is it common that you'll have an infestation in a warehouse that has multiple different species inside of it?
You certainly can. It depends on that layout of the warehouse. It's most of the time they tend to be specific, especially with the beetles. You can certainly have overlap, like cigarette beetle and warehouse beetle will occupy the same spaces sometimes. And that Mediterranean flower moth and Indian meal moth will commonly share spaces. But In terms of individual food patches, not very often.
Okay. With the treatments as well, like you use the mating disruption as some of the treatments for these issues. However, you talked about like fumigations and other applications. I was just like curious as to how that works when you're dealing with food products that are already like finished. Like, how can you spray something? I mean, I work with agriculture, so I know for us, like you need to have a certain period of time that you apply an insecticide before, you know, you harvest the crop itself. So like there must be so many issues that come into play when you're spraying. What are you spraying in a warehouse
Right.
to deal with this issue?
That is a real challenge. There are a lot of limitations, and the tools that you have available for treatment are not that many in terms of chemical treatment. So yeah, spraying finished food product, you can't do it. You can spray around the areas where finished food product is held, but ultimately fumigation is your only option in certain scenarios, just because it does not leave a residue behind. So.
Is there a threshold as well as like particularly thinking about the domestics that you were talking about in the baby food warehouse? Is like, what is the threshold of having these pests in your finished product as like a still marketable good?
For most food products, as far as the manufacturer is concerned, it's gonna be zero.
Okay.
If they're finding if their quality control people are finding actual live insects before it leaves their facility, it they should be putting a stop to that going out of the building. Whether that always happens, that's debatable.
Yeah, I can imagine it doesn't, because I've definitely gotten Indian meal moth from the grocery store.
Right, and a lot of the time, a lot of the time those infestations aren't always happening at the manufacturer. There's lots of places along the way for it to happen. So a lot of foods end up at distribution centers and in the back of trucks, where they get mingled with all sorts of other food products from other manufacturers. So if 90% of the actual food processor manufacturers don't have a problem, but that 10% does, they're spreading it to everybody else as it gets held in a warehouse.
Yeah.
So yeah, one of the biggest places to get stuff is really at that grocery store, or at that grocery store distribution, one step back.
Okay. Oh, wait, I had one more question too. So this was in regards to the domestics again, that little story that you said about that person who froze it and then they gave it to
Yeah.
you and they molted 12 times.
Yeah.
How many times can they keep molting, and how long has that thing been alive? That seems so unnatural.
I'm a little surprised with that one, because all of the literature says that it really shouldn't be going past a year or so for warehouse beetle. I mean, you can find different people saying some different stuff, but I'm coming up on 2 years at this point, and he's still alive in there. And
you don't feed him or anything? He's just
he's got a little tiny piece of a domestic food lure that we use as an attractant. But it's got a bunch of different proteins and insect parts and stuff in it. But it'll barely eat it. And part of the reason why I think it's lasting so long is because I really am disturbing it so often. I'll pick it up and roll it around and look at it every couple weeks. And so that disturbance, I think, resets it says, oh, forget it, I'll hang out.
It's crazy. All right, thank you so much.
Yep.
Hi, James. I have a question for you.
Mm-hmm.
So you talk about competitive and non-competitive mating disruption.
Yes.
So what's the difference in the lure? Is that the amount of lure present, or something else?
It's two things usually. The biggest is the amount on the amount of lures that you set out, and the material that it's made of. So most of these lures end up being like 165 milligrams per lure, but they'll have different labels on the back, and they'll say, okay, well, you need to set this out according to square footage, this many lures per square feet, which doesn't always make sense. It's not the greatest label, because food facilities can have different ceiling heights. So, and we're talking about a three-dimensional issue, where like other products will say it is by cubic feet or cubic meters. And And I believe that that some of the materials they use are different. So even though they're starting with the same amount, 165 milligrams, it's slightly different materials and a slightly different number that they're setting out. So that's where you end up getting that competitive versus non-competitive is more something that we've kind of assigned to describe those products for ourselves.
But the most commonly used is 160 milligram per lure, right?
Yeah.
So that can last for like a half a year. So at the end of it, would that be more likely competitive or more likely not competitive after the end?
I think you're probably right. I would imagine by the time that by the time you're getting to the end of it, that the model might be changing over to that competitive model.
Okay. And we also found that the Indian meal moth lure can attract a lot of cigarette beetles. So the pheromone seems very similar, or at least attract both species, right?
Yeah, that's interesting. I haven't seen that as often, although we usually when we go after cigarette beetles, we'll put in a multi-species lure already. So we'll put in both cigarette beetle and Indian meal moth in the same lure. But I'll have to see if I can see that.
Okay, we can discuss our meeting.
Yeah. We do catch a lot of our Indian meal moth lure because it's produced in the same facility as our closed moth lure. There is sometimes some slight crossover because it's some of the same pieces of equipment. Anyway, the point is we can put an Indian meal moth lure in a facility, and there's another insect called the brown dotted closed moth that is attracted to regular webbing closed moth pheromone, which is there's a slight amount of it on the lure, right? So we'll find people at a facility might freak out and they'll say, oh, we caught so many of these moths. We've got all these Indian meal moths. I'll go out and look at it and go, this is brown dotted closed moth because they're attracted to that webbing closed moth pheromone. And then they'll say, well, why do we have them? I go, well, you've got a bird problem. And then they insist up and down that no, we don't have a bird problem. And then you press them on it further and they go, well, we did have a bird problem 3 years ago and there were nests everywhere. I was like, well, did you clean the nests out? No. There you go.
I had another question.
Sure.
Regarding the Indian meal moth, you say that they lay their egg close to like an opening or maybe not, but what if there is no opening? Like, is there an amount of time that the Indian meal moth first instar can live before it does have to find its food?
Yeah, I don't know off the top of my head exactly how long it is, but I know that it is not very long. So they do need to find food as fast as they can. So yeah, if they don't find it, it's not good. But usually the female will try to wait until the last minute to do that, to find the perfect place to lay eggs.
Hi, Karshan. I think I can answer your question about that, because in our lab I found that when the newly hatched instar, they can feed on the dead adult body.
Mm.
Yeah, I think if there's no food around, they can survive some time. So when I was studying in the lab, so the first instar, they can survive for more than 1 month only on the dead body.
Oh wow.
Yeah, but the number was very limited for there's not much to survive to nest instar, but they can.
Interesting.
Yeah,
That's impressive. 1 month. Oh, that's really bad too.
yeah. Yeah, but only a few of them.
Sounds like a last ditch survival technique. We're not all going to make it, but maybe some of us can.
James, another question. So do you have any concern that say you are putting a lot of lures for mating disruption, then you open the garage door or the building door most of the day, would that be something they can attract a lot of Indian meal moths from outside?
Yes, that kind of thing can happen if there is that large presence of Indian meal moth outside. You can also run into that scenario where you open the door and you let all the pheromone out and it doesn't really work as well as it's supposed to. But yeah, I've talked with some of the guys that set this out more often than I do, and they'll discourage a facility from a facility might ask for mating disruption, and they might discourage its use if they can't convince them to keep the doors closed, or if there is a scenario where there's lots of cross ventilation, because it's a lot of money to set it up and a lot of effort. And if it doesn't work, then nobody's happy.
So basically minimize the time opening the door.
Yeah.
For the building. Okay.
And the good thing though about, because it's a sex pheromone and it's really only attracting the males, it messes with your numbers, with your catch rate, but they're not actually gravid females coming into the building and laying eggs on stuff.
I have a question for you.
Sure.
So you mentioned that you have this newer technology where you can measure the pheromone. That you were using the example of like an infested tractor trailer or something like that.
Yeah.
Is there a way that you can, let's say you have even if it's not mass trapping, either a mass trapping, like mating disruption or just regular monitoring in a warehouse, is there a way that you can monitor the pheromone level and pheromone distribution? Because obviously you could have a program set up and to your point, you can have airflow, air circulation that is taking your pheromone to a place that it wasn't intended to be. You can have uneven distributions. Your program is not delivering the material where you want it and the way you want it.
Yeah.
Can you monitor and see what kind of levels you have and what the distribution is?
I think that is a fascinating question. And I think that no one is doing that, but I think that with that technology, that would be a really great use of it.
Right, because without it, you have no way of knowing whether you're achieving what you set out to achieve in terms of just a distribution of pheromone.
Yeah, especially with mating disruption, you would have a heads up that something's going wrong here.
Right, you would know that this isn't going to work because the pheromone's not staying where we want it to stay, or our monitors are not going to provide us accurate results because the pheromone is not where we think it is.
Yeah. Yeah, I appreciate that question. That's I'm writing that down. I was looking in the past at some of my past presentations, especially from colleagues getting ready for this, and they had talked about, I don't know, probably 12 years ago, one of them had mentioned this idea of attempting to use static, like gas chromatographs, even before this new sensor technology, to see if they could have these stationary units that just lived in the building, and then you could constantly monitor the pheromone levels, but no one seemed to act on that. So
yeah, okay. Well, say hi to Tom. Send my regards to Tom and Dave.
Yeah, certainly.
Okay.
So James, another question: when you do mating disruption, do you recommend using the fans to circulate the air in the warehouse?
I don't really. I guess I'd have to think about that. I don't make any specific recommendations about fans. I would think that if you could, I don't know, you'd kind of want to see what the natural airflow in the building was like, and then see what it is with the fans, and and try to determine if the fans really are moving mass quantities of air. Maybe it's not the greatest thing, especially since sometimes they try to do targeted mating disruption where they may not actually treat the entire structure. They'll try to just say, I'm going to do just the warehouse space, which is difficult because the pheromone doesn't want to necessarily stay put where you release it. So I would imagine fans would make that situation worse.
Right. So we are using the SideMax from the Tracy company. So they are trying to say you put several fans at the corners of the warehouse,
Yeah.
Let the air circulator so that the lure will evenly distributed within the warehouse. It's a huge warehouse
Yeah.
with thousands of bags of products. So they
Yeah.
want the lure to be evenly distributed. Without the fan, they said the lure may be concentrated in certain locations.
Yeah. I don't know. I would be really careful setting up that program and doing fans, especially. I think Sidetrack is I think they're the ones that the label has it by the square foot,
Right.
rather than
by cubic.
their cubic foot. Okay. Yeah. Interesting.
Anybody has questions? It's already 12. If not, I will thank you, James, for excellent presentation. And
Yeah.
we will stay for another hour for those students who register for seminar. And then we have a 5 minutes break.
Great. Thanks.
Okay.
Thanks again for having me.
All right. Thanks.
Thanks.
So those who register for the seminar can stay for another hour. So come back at 12:05. All right.
Thank you.
And just double checking. And what am I doing?
James, so there will be about 10 students registered for the class. So we'll basically, introduce the students to you and they can ask you questions,
Sure.
be more casual than the seminar. So basically, it's like a discussion about, whatever you talked today.
Sure.
And if you want to have a break, you can, drink water or whatever. So, and after, I think 1:30, you, me, and my students will discuss with you about our research on Indian wheel moth.
Great.
Yeah. Is Tom? Tom is older, right? Older
Tom?
than Dave. Tom and Dave?
Oh, Dave is the father. Tom is the son.
Oh, sorry, Dave is the father. Okay. Dave retired, right?
Dave is retired. He retired in 2018.
18. Oh, okay. Tom is working. Okay.
Tom is working. Yeah.
All right. Compared to your, you have a Indian wheel moth lure, right?
Uh-huh.
How different is yours and the Sidetracks?
So Tracy has their own Indian meal moth lure. We don't have a mating disruption.
Oh, I see.
Their lure, I think, is a septa and or a small piece of rubber. Ours is that bullet lure. It's a little vial with a cap on it.
Oh, I see. Okay. Okay, I'll come back.